bad. So before I start, out of curiosity, who looked at the repository I posted? You can lie, it's totally fair to lie. Okay, is the Good Samaritan who found the code in my broken repository here? So you saw that it didn't work? Did you, someone was nice enough to actually put in a pull request like 2 hours ago, 3 hours ago. So if you tried it and you found it didn't work, it should work fine now. But by the time we get to that point, it probably won't matter, so don't worry about it. All right, with that being said, actually also out of curiosity, just before I get started, how many people have experience with Kibana? How many people used it? Handful, most of you guys haven't. You guys are pretty fresh. Okay, that's good to know too. All right, now let's jump into it. So as you can see, I'm a pretty big fan of exciting and fun titles for presentations, which is why I chose to call this an introduction to logging architecture and security analysis. I'm not going to spend too much time here because Garth already gave me a glowing introduction with the material he had to work with. Outside of what he said, I guess the big thing to keep in mind is historically I've almost always been a blue teamer. So this presentation is very defense oriented and is very focused on that area of analysis. The other thing, I definitely don't know everything. The things I'm going to talk about today, what I'm going to mention today is based on my own anecdotal experience. If you happen to think something I say is absolutely ridiculous or that I'm completely off base and an idiot, feel free to message me privately in Slack or chirp me politely during this presentation. Game plan for today. Nothing super crazy. We're going to touch briefly on why logging is important. I'm going to give you an overview of a common logging architecture, which I think is pretty sane. We're going to go into analysis concepts, and then finally there's going to be an exercise with some prizes. Long story short, I'm going to try to bore you for no more than 20-ish minutes, and then we'll do some hands-on stuff. So why does logging matter? Obviously the only reason is because it's an OWASP top 10 item now. But outside of that, the thing to keep in mind with logging is you can't catch what you don't see. If you're not watching for things, if you're not logging, you're not going to notice if there's a compromise or if someone slipped through your defenses. The other thing is, once you get good at logging too, it can also become a method to be a bit more protective. So for instance, often within your logs, you're going to see potential indicators of things, bad things about to happen before they do. Potentially reconnaissance on your infrastructure, maybe people are scanning. That sort of thing, which will hopefully give you a leg up when the actual attack does occur. The other nice thing with logging is, so unfortunately, depending on your organization, security is probably not going to be the biggest priority. But logging is something they should already be doing. So from an operations perspective, even outside of security, you're going to be doing logging to know, for instance, is my infrastructure up? Is everything working as expected? Are users able to successfully complete requests? And in that context, you'll typically hear two acronyms come up a lot, RED and USE. So RED stands for requests, errors, and duration, which is fundamentally how many requests are we serving for our application, what percentage of them are resulting in errors, and how long are they typically taking. The use, utilization, saturation, and errors is typically more hardware focused. So you're looking at things like what are our hard drive spaces, or what does our hard drive space look like in terms of utilization. Saturation would be, are we under provisioned for the amount of resources that our application needs? And then finally errors again, are things breaking? So keeping in mind, operations should already be doing logging. From a security perspective, you can kind of take the approach of embrace, extend, extinguish. So embrace in this context would be, okay, you're doing security for your organization. Meet with the development teams. Meet with the applications teams that are already doing this sort of work and find out what they're logging. At this stage, you're doing more exploratory work, and what you should be trying to do is, when you're listening to what they're already capturing, keep in the back of your mind, how can this apply to security? How can I incorporate what they're already logging, potentially in the context of like RED and USE, and use that as a way to improve my organization's security posture? Ideally then, step 2, you've got some goodwill after doing the embrace stage, you start working on extending your influence. So again, you go back to those teams and you're like, okay, it's great that you guys are doing this, but have you thought about maybe, I see you're logging IP addresses, enhancing that with maybe some information from a threat intelligence suite. And this is where you start to kind of put more of a push into getting security actively involved in part of that logging process. And finally, extinguish. Extinguish in this context is probably a little Machiavellian, but we'll take it to mean through your pilgrimage of embrace and extending, you've increased the logging or the impact of logging in your organization to a point where you're catching all sorts of security incidents, and your security posture is greatly increased. Like I said, I tend to bleed blue, but I do want to make a quick pause for the red team before I neglect you for the rest of this presentation. Logs often contain treasure. Recently, Facebook got dinged because they were logging credentials for their users. That isn't to say that credentials were stored in clear text in a database. It was during the login process the actual credentials were being captured. Another good article here worth looking at, a group of researchers went over the public build logs of open source projects and combed those to find things like API keys, access keys, user credentials. So although it's important to log, you have to be mindful of not logging sensitive things. And as a red teamer, if you stumble across logs in an organization during an engagement, definitely have a look there because there's probably going to be something juicy. So that said, feel free to go back to writing spear phishing emails. All right, logging architecture time. Before I jump into it, this section is basically completely ripped from this book. Very good. I stumbled across Securing DevOps actually in the OWASP Slack channel, so if you're not already in it, definitely hang out there. It's a great overview of kind of doing the whole secure DevOps pipeline from start to finish, including doing things like risk assessments, and there's also an excellent case study. Like I said, my architecture mirrors what he recommends in the book pretty closely. I do disagree with a few points, but we'll get into that as they come on. So, main components of a logging architecture to consider: collection, streaming, analysis, storage, access. I'm going to talk about these briefly throughout the next couple of slides. Realistically, each one of these warrants its own topic in its own presentation. The other point that I'm not going to bring up is at all these layers, there's also security considerations to consider. So you're dealing with things like encryption at rest, encryption in transit, your access controls, all of those things apply here, but we're not going to touch on those. It's an exercise left over here. All right, step one, collecting. Probably the hardest part, in my opinion, of this whole process, because there's so many options. You can do logging at an OS level, you can do it at the network level, you can do it at your application. Typically, it's going to be distributed, right? You're dealing with multiple applications, especially if you're looking at a microservices architecture. Big thing, if you can be involved here, and you probably are because you're all good practitioners who are trying to move left in your organization, it helps to try to champion standardization. So by that I mean, you don't want to be in a situation where you're collecting logs, but every application team has a different format. Maybe some of them are using date timestamps. Maybe some are just giving you the Unix time. Maybe some have information about what the application source was, and other people don't do that. So ideally, if you can get everyone to sort of structure their logs in the same way, it's going to make things much easier for you when it comes down to doing actual analysis. In terms of collection, three main areas you're typically going to have trade-offs: granularity, resource impact, and detection times. So by granularity, I mean you're going to have to make decisions in terms of what you actually log. So how verbose, what information are you going to collect? Also, granularity will involve how frequently you collect it, and there's a balance there. If you collect very verbose things, you might not be able to do it as frequently as if you tone down what you collect and you do it more often. Resource impact is another big one. And by that I mean you have to consider whatever method you're using to log can't be more expensive from a resource perspective than the actual application you're trying to monitor. Otherwise, your operations team and your application developers are going to be very upset when you ask for more hardware just so you can log more. And the final trade-off is detection times. And this kind of ties back into how frequently you collect data. And there's a balance here between, for instance, you don't necessarily want to only collect logs once a day. That's not going to help you. You're gonna miss things, even from an operations perspective. If it takes you 24 hours to realize your service is down, your customers are going to be very upset. That being said, you might not have to do it every second. It might be all right to delay your logging a minute or a couple minutes, and you'll still have a good balance between detecting things fast enough, but not overwhelming the other elements. So at this stage we're collecting. We know what we want to collect, we're getting the data, how do we get it back? This is where streaming comes into play. Most often here you're going to be using something off the shelf, common solutions rather than Q. If you're in the cloud, Event Hub in Azure land, Kinesis in AWS land, it's fundamentally going to be the part of the architecture where all the data you collect gets centralized so that it can be processed and dealt with by other elements of the architecture. When I first did this slide, I kind of had stopped there and neglected it because I was like, Stream, what are you going to do? You're going to install or whatever. You're going to use Kinesis and it's going to be over. But Garth actually presented a good question. I lost him. I don't know where he is. Oh, there he is. And he asked, well, can you talk a bit about TCP versus UDP? And it turns out, with regards to that question, you're not usually going to even have a choice. Most of these applications are going to be using protocols which are based on TCP. So MQTT, AMQP, even HTTP, depending on what you're using. So that decision is made for you. That being said, most of them will also have a TCP to UDP bridge that you can take advantage of that might solve that problem. However, unless you're in an environment where it's a hard requirement that you need to use UDP, it's probably not the area I would focus on if I'm trying to get bonus performance. Realistically, if you can look at your frequency of collection and your payload sizes first, I would do that instead if you're trying to get some performance gains. The nice thing by focusing on that instead of necessarily TCP or UDP is you're going to get benefits in the other areas. So for instance, if you're collecting data a little less frequently, you can store it for longer periods of time. And similarly, if you've got less data to look at, it's usually a little faster to access.
Question.
Shoot.
Sorry, yeah, to me again on the TCP thing. The problem with, yes, if you're using infrastructure that's using these protocols and it's chosen for you. If you're working with something that's been around for a while and the political problem is trying to get people to change their verbosity, and that's sometimes a harder thing to do across multiple teams than to just start using UTDP because of bandwidth restrictions.
Yeah, for sure. I mean, that's always going to be tough, right? And that's kind of where, in an ideal world, you get involved early if you can, but that's not a realistic world always, right? So you're kind of stuck with what you have.
Join a startup.
Sorry?
Join a startup.
Yeah. Right, yeah, build it from scratch. Again though, I mean, depending on the situation, a lot of these technologies will have some sort of way for you to use UDP, even if it's not for everything. All right, so we're collecting. We're streaming it back. Now, where do we put it? Two main things you're going to be considering here are hot versus cold storage. Hot storage you can consider is fundamentally, it's available to you in a way where you can quickly do analysis. You can access it, you can either query a database that will be readily available. Maybe it's loaded into memory in a data frame. Either way, it's available now. Cold storage, on the other hand, is the exact opposite. It's basically, you've put it on a drive, you've zipped it, you've tarred it, whatever, and you throw it in the closet. There's going to be a process for you to actually get access to that data. It's not readily available. You've either got to extract it, maybe you have to load something off tape. The storage it's on is much slower. You can't just start doing analysis on it. Nice thing with cold storage though is that it's relatively cheap. You can get spinning Rust drives now, multiple terabytes, and sub under $100. So you can keep things historically for a very long time, ignoring data retention policies for a second. This becomes very important if you eventually have to do forensics. Chances are sometimes in your career, or at some point in your career, you're going to get compromised. And when that happens, the more data that you have to go over, the more data you have to look at, the better it's going to be for you. Hot storage is a little trickier. If I was starting somewhere from scratch and it was like bare bones, how much data do I need to keep in hot storage to do analysis? I usually say at minimum 7 days, ideally with some aggregation statistics on top of that. That being said, it depends, right? If you're doing analysis every day, you can get away with a shorter window because you're going to have a bit more of a feel of what the logging patterns are within your organization, what the spikes are, what the ebbs and flows are. If you're only looking at the data maybe once every other day, maybe once a week, you're going to want a little more information in hot storage than just a week. That being said, once you start getting to the point of over a month, I think there's a bit of a diminishing return from my experience. The application we're going to be looking at the logs for later on during the exercise receives about 3 queries a second over the course of an hour. Napkin math, that's what? 7 million and change requests a week? Or no, not 7 million, sorry. You're looking at maybe around a couple million of requests a month for a single application. You have multiple applications you start monitoring, and that quickly becomes overwhelming, and you start having a lot of data in your hot storage. Plus, you're never really going to look at it. So I find a month is kind of a sweet spot. A month to 3 months is all right. Anything over 3 months, and you're probably never looking at it, you're just wasting resources. All right. So we're collecting, we're storing. All right, we're collecting, we're streaming, we're storing. How do we access it? This is now, after the TCP UDP Fandango, my new slide of neglect. Basically, there's all sorts of ways to access it from user interfaces, APIs, depending on what database you have. You'll have client or command line interfaces. The world's your oyster here, really. We're going to be using Kibana later on, as you guys probably already guessed. But at the end of the day, if you're in a pinch, if you're in a situation where you don't really have any other access methods, you can get pretty far with just command line tools. So a bit of grep, a bit of sort, a bit of unique, some cutting, and you can do a decent analysis job. It's not ideal, and if you find yourself doing that frequently, I would highly recommend looking at other options. But if it is what you have, it is what you have. All right, we're getting to the home stretch, analysis. This is the part of securing securing DevOps that I don't fully agree with. The book talks a lot about doing analysis on the screen. Not my ideal choice, and I'll explain why. When you're doing analysis on the stream, you're going to start dealing with 2 things, state and stateless. So you can consider stateless as you're watching the stream go by, and you're just looking at individual log events or whatever is going through the stream and trying to make your decision of, is this good or bad, just on that individual piece of data. When you shift to state, the idea becomes we're going to look at a number of log files as they go across the stream and try to get a bigger picture of what's happening and a bigger understanding of what's going on between these files. Where that becomes difficult, though, is deciding how much state are we going to keep. So how many messages are you going to try to keep stored in state, or you're going to try to do it maybe based on a sliding time window where it's like, okay, we're going to try to maintain a live picture of operations of the last hour by feeding directly from the stream. But then if you take a time-based approach, what happens if all of a sudden during that period you have a huge spike in messages, and then all of a sudden your method of trying to maintain state falls over? The other point to consider is if you're using something cloud-based, often you're limited to how many things can actually subscribe to the screen or to the stream. Instead, my preferred method is actually doing it at the storage layer. So again, kind of in a cloud-based context, usually streaming software will write out a file after some period of time, so either it's a minute or it's 15 minutes, and I like to work directly from those files instead. It goes back to that trade-off of detection time, but typically a 15-minute delay of processing data that's live is not the end of the world. And most of the time you're not going to be sitting in front of your workstation watching things happen live. So it'll be usually you come in at 9, 10 a.m. if you're me, and you look to see what's happened in the last 24 hours, in which case the stream, what happened directly on the stream doesn't matter as much as the processing you do after the fact. So let's start diving a bit more into what analysis is and what you're trying to accomplish when you do it. I really like this quote, so I'm going to read it out loud. Whether a deviation from normal operations within an organization is an incident. So I stole that from Securing DevOps, as I do most things, and I believe in the book they credit it to Sand. So what does this mean? Basically, you're looking for things that don't normally happen within your organization, right? And that can boil down to frequency and time. So when I say that, I mean we're going to be looking for either 2 primary cases, where lots of something happens in a short time window that usually doesn't, or the exact opposite, something that rarely ever happens. So that one's a little harder to explain, but you can think of it as you're looking for instance, a user running an application that they would never run. Or maybe a path on your web application gets hit from a public IP address that should never be publicly exposed to the internet. Those are kind of the outliers you want to identify. A way I often structure my data to capture this is considering the relationship between the first time I've seen something happen, the last time I've seen it happen, and kind of the frequency in that time window. All right, we're going to level up now. At this stage, you've got your analysis to the point where you can identify when there's a lot of something happening that shouldn't be. You can start picking out things that shouldn't happen in your logs, and regardless of the frequency or time. What do you do next? So at this point, what I would start to recommend is looking at ways to enrich your data. For instance, incorporating things like intelligence feeds, adding additional information to your logs. One of the things this will start enabling me to do is working towards building reputation. And by that I mean, for instance, let's say you've incorporated OTX. So OTX is Open Thread Exchange. It's basically a feed that you can subscribe to that will give you lists of IPs that are doing bad things, domains that are bad, hashes, all sorts of juicy things. So you see one of your users is coming from an IP address that has been flagged on OTX. That doesn't necessarily mean they're guilty out of the box, right? But even if they're not doing anything at that point that you would have caught based on frequency and time, it's still worth knowing, like, okay, this person is using an IP which has been notorious for doing bad things on other sites. They haven't done anything bad to us yet, but let's keep an eye on what this behavior is. Maybe this user's account has been compromised, and we should be aware that this guy doesn't have the best reputation. Fundamentally, you're trying to answer, do I trust you or not, and to what degree? And the second thing to consider at this stage too is starting to incorporate some statistics. It doesn't need to be anything crazy, but going a little further than just frequency and count, but doing things like looking at your averages. So your means, your medians, your modes. Determining, for instance, maybe you're starting to see a spike in traffic that looks like it's kind of crazy, but it's within 1.5 standard deviations of what you normally expect anyways, so it's not enough to warrant alarm. Finally,
A little publish as well.
yeah, absolutely, totally. Yeah, I tend to prefer to be a little text heavy than picture heavy, just because I've been doing some volunteer work with an organization that's very, they basically provide textbooks for the blind, so they do a lot of text to speech. So sorry, there's not a lot of pictures because I'm very cognizant of pictures. Blind people can't see pictures. Anyways, back on track. Level 3. Time to do some cyber bingo, ML, machine learning. At this stage, you've got your basic analysis down. You've started incorporating threat feeds. You've got a bit of reputation work going on, and you're like, what's next? How do I get even better at doing logging and analysis? Isolation ports, neural networks, like GBMs, those are the sorts of things that you want to be looking, potentially researching and incorporating into your analysis environment. There is a lot of research in terms of detecting outliers in time series data, which is awesome. The thing to be cognizant of, though, is not a lot of it is written in the context of security. So when you're starting to look at this sort of stuff and starting to go down these rabbit holes, you might have to take a step back, look at sort of more general machine learning that's occurring, more general practices, and then think, okay, so this person did this time series forecasting for stocks. How could that potentially apply to what I'm doing with security? Another great source to check out is Kaggle. So if you're not familiar, Kaggle is basically a site that hosts data science competitions for individuals. The nice thing with Kaggle is at the end of competitions, usually the people who've done very well will share their solutions. So it's often a good source of finding some sample code to work with. And they do from time to time have security-focused competitions. So malware prediction, there was another one recently by Microsoft where they provided a data set of user behavior, and you had to try to identify which of these users was most likely to be compromised next. So things that are definitely relatable or definitely usable in a security analysis context. However, really like this expression, Abby, ain't gonna need it. You're gonna get really far with level 1. If you just look at frequency and counts, to be honest, or frequency over time, you're gonna detect the bulk of things. So kind of crawl, walk, run, you're gonna get a lot of mileage here. So with that, what we're going to do, because most of you guys are data newbies, just a quick overview. This is going to be like a...
Can you make your text bigger?
Alright, perfect. This is why the volunteers are great.
Let's hear it for Paul.
So since no one used the other repository, you won't have to do this. If some of you did and you just didn't want to raise your hand, you might have to remove the Elasticsearch container because I'm lazy at naming things. So basically we're just loading up Elasticsearch Kibana, and once it's fired up, it's going to load the access logs. And the steps I'm going to go through here initially are what you're going to have to do on the exercise, so pay a little bit of attention. Or don't.
Question.
All right. Yep.
So the full out stack is just in Docker Hub.
Yeah, everything. But so for the exercise, we're doing elk minus the elk. So it's just Elasticsearch and Kibana, and I'm manually loading the logs.
Okay.
So step one, what you're going to do, these are also documented in the repository, probably poorly, but we're going to go to settings, we're going to save objects, and we're just going to import the pre-made dashboards and stuff that I did for you guys. It'll be underneath Kibana dashboards. And don't worry, I'll go over this again, and if you run into problems while you're trying to do it, I'll be here. Perfect. So the first thing, we're going to look at two main areas of Kibana. We're going to start with the dashboards. So fundamentally what the dashboards are just a summary of, or they're aggregation statistics of the logs that have been loaded into Elasticsearch. For the purposes of this exercise, basically everything should be solvable just from the dashboard. One of the things to keep, or one of the nice things with Kibana is basically if you see anything in a dashboard, you can click on it and make it a filter. So in this case, we've got status codes here. Click that, we can see now all the logs that have a status code with 200 are what we filtered. Really holds true for any other part. So that's time histogram highlighted. That's now the area of focus. The other thing that's good to know is you can do something called pin this across all apps. So let's say you find something in the dashboard and you want to see some more details on it. That's where we would go here, top left, to discover. We can see our status key 100, or status 200 is still here. And what the discover area of Kibana lets you do is see the actual raw logs. So again, this is actually the information that was captured, not just a summary view of it. We can see the logs themselves are based on Nginx access logs. So if you're familiar with those, none of this data should be surprising to you. And all the filters that you can kind of apply to any of the fields within the data are available in the team. So I can see the refer, there's no refers. If we want to filter on just a specific user agent, it's easy. To be honest, it's not anything crazy confusing, and most of the interaction is straightforward. The big thing you need to remember, if you can click it, you can filter on it. I guess the only thing I didn't mention is you can include or exclude results. So for instance here, we've looked at status code 200. Let's say we want to look at everything that isn't a 200, we would exclude those results. And in this case, there were no 200s, no situation where this user agent didn't have a 200. That's it. So that was your instant back. Sir. That's a quick overview. And from there, finally to the point where I can almost stop talking. Exercise time. So as I kind of hinted here, we're going to use Elasticsearch and Kibana. Elasticsearch is going to be storage, Kibana our access method, and you're going to do analysis. Collection and streaming is done. You don't have to worry about that either. Within this data that you're going to have access to, 3 compromises, or 3 incidents, let's call it that. Because I don't want multiple people putting their hands up at the same time and having to decide who put their hand up first, post a message in Slack and that's how I'll decide you've got a solution. Main 3 things I want to know: what happened, was it successful, and what are your next steps in terms of remediation or further investigation. 3 incidents and 3 prizes available. If you win a prize, you can win another one just to try to share the loot in case there's Kibana hustlers out here. And also play nice. So don't be a jerk. Don't try to mess with other people. If you see someone struggling, help them out. I'm only one person. I'll try to do my best, but it may not be feasible for me to get to everyone. And oh, I guess the prizes that you're playing for. I guess I should tell you that there are 3 $20 Starbucks gift cards available here with an estimated retail value of $20. So the prizes are real. The only thing I need to do here still is make the repository public, and then we should be